In this video, we'll take a look at section 8.2, the graphs of the other trigonometric functions. We've already taken a look at sine and cosine in the previous section, so now we're going to take a look at tangent and then all of the reciprocal functions. So the graph of tangent, remember that tangent is equal to the sine divided by the cosine. So the graph of the tangent, wherever the cosine is 0, the tangent is going to have a vertical asymptote. So if we take a look at and plot points between negative pi over 2 and pi over 2, the exact values from the unit circle are listed, and then the decimal values are listed. At negative pi over 2, the tangent does not exist because sine divided by cosine is 0. So at negative pi over 2, we have a vertical asymptote. Then at negative pi over 3, we're graph at about negative 1.73. Halfway in between is pi over 4, which is 45 degrees. A little bit further to the left is negative 1.73. At negative pi over 4, we have negative 1, 0, 0. Negative pi over 6 is negative 0.58. Then by symmetry on the other side, at pi over 6, we have 0.58. At pi, we have 1, and at pi over 3, about 1.73. When we reach pi over 2, we have does not exist again, so there's another vertical asymptote. If we sketch in our points, one cycle of the tangent function happens between negative pi over 2 and pi over 2. So the characteristics are different, much different than the sine and cosine. So the domain of our function, notice that the vertical asymptotes occur every pi, and they start at pi over 2. So a way to write your domain is pi over 2 plus any multiple of pi times k, where k is an integer. So at pi over 2 and every multiple of pi, add any multiple of pi, you get another vertical asymptote. So that means you could also subtract pi. So those are all the places where we'd have a vertical asymptote. And those are also all the places where the domain is undefined. So it's all real numbers except those values. So that means that the asymptotes are x equals pi over 2 plus pi over k, where k is an integer. The range, notice the values that y can be are all real numbers. And then the period of the tangent function is equal to pi instead of 2 pi. And the key points that we use in graphing, when we're graphing with transformations, it's easier to transform these particular points. Negative pi over 4, negative 1. 0, 0. And pi over 4, 1. The reason why these are the key points is if we're doing a vertical stretch, we're multiplying the y-coordinates by a value, so it makes it nice and easy to multiply negative 1 and 1 by the value. And 0, 0 is the intercept. And then the asymptotes are another key feature of the graph that you draw in. So let's take a look at a transformation of the tangent function. How would you graph y is equal to a times the tangent bx minus c plus d? First of all, make sure your function is expressed in that form. Identify the stretching or compressing factor, which is the absolute value of a. In sine and cosine, that was amplitude. Tangent doesn't have amplitude. Identify b and determine the period. This time period is pi divided by the absolute value of b instead of 2 pi, because the period of the tangent function is pi. Identify c and determine the phase shift, c over b. Draw the graph of a times the tangent bx first, and then shift it to the right or left by c over b and up or down by d. And then sketch in the vertical asymptotes. and it says plot any 3 reference points. It helps to use your 3 reference points as those 3 key points. So here's our example. Y is equal to 2 times the tangent 2x plus pi over 2. In this example, a is equal to 2. So the absolute value of a is equal to 2. That's the vertical stretch. B is equal to 2. So the period is equal to pi divided by b. So the period of this tangent function would be pi over 2. The phase shift, since we have 2x plus pi over 2, is going to move to the left, pi over 2 divided by 2. Pi over 2 divided by 2 is the same as pi over 2 times 1/2, which equals pi over 4. So when we draw the graph, I'm going to sketch in, first of all, just the graph of 2 times the tangent 2x, and then we're going to move that graph pi over 4 to the left. So if the period is pi over 2, 0, 0 is the middle of the graph. So if the period's pi over 2, we're going to go to the right pi over 4 and to the left pi over 4. So our vertical asymptotes are at pi over 4 and negative pi over 4. Then halfway in between 0 and pi over 4 is your first key point. In the original graph, the y-coordinate is 1. In this graph, it's a vertical stretch of 2, so the y-coordinate is going to be at 2. So that point would be pi over 8, 2. On the left-hand side, we're going to go to the left pi over 8 and down negative 2. Sketch in using those 3 points as your guide in the vertical asymptotes. And that's the graph of 2 times the tangent 2x. So now what we want to do is we want to move the graph to the left pi over 4. So that means each of your vertical asymptotes moves over. Each of your coordinates moves over. Move over. There's both of our horizontal or vertical asymptotes. Move over each coordinate and sketch. So the graph in the pink is your final answer. Then you have a vertical asymptote at x equals negative pi over 2 and another at x is equal to 0, okay, in the final graph. So that's the graph of tangent. Then the reciprocal functions, if we take a look at cotangent, that is equal to 1 over the tangent. So wherever the tangent is 0, the cotangent has a vertical asymptote. So if you take a look at the graph itself, if we look at the characteristics, the domain is all real numbers except the places where we have a vertical asymptote. In this case, they're multiples of pi. The range is all real numbers. The period is the same as tangent, it's pi. And then the vertical asymptotes, the equation is x equals pi times k, where k is an integer. And then if you want to graph, a general note on the properties, a times the cotangent bx minus c plus d, then this outlines how you find each of the values to be able to sketch. So if we take a look at cosecant, that is the reciprocal function of the sine. So cosecant is equal to 1 divided by sine. So that means vertical asymptotes occur wherever the sine is 0. So if you look at the picture, at the graph, sine of x is in orange, and then the reciprocal 1 over the sine is the cosecant. So in this graph, the domain, we have vertical asymptotes every pi again. So the domain are all x values except x cannot equal multiples of pi. The range, notice, does not equal anything between -1 and 1. So the range is from negative infinity to -1, and then 1 to infinity. The period is the same as the period of the sine function. The period is still 2 pi. And then the vertical asymptotes have the form x is equal to pi times k multiples of pi, where k is an integer. And then if you want a graph, you've got general features here. So just to let you know, you can certainly graph using Desmos. So I'm going to go ahead and open Desmos and just show you. So you can graph trigonometric functions using the Desmos calculator. If you want the x-axis to be in terms of pi, then your x-axis, you can type in -2 and then pi will turn into a pi to 2 pi. And then if you want them to, the labels to not be integers, if you want the labels to be in terms of radians, put in for step either pi over 2 or pi over 4, whatever, or pi over 3. You can put whatever you want. If I put pi divided by 2 to match the grids that I have, this is how you get a trigonometric function on there. And then make sure radians are clicked. So you can type in a cosecant. Y is equal to the cosecant of x. And there's our cosecant function. If you want to graph transformations of that, y is equal to 2 times the cosecant x minus pi over 4. I'm just making things up. Then you can also use Desmos to graph. Okay. All right, last function is the secant. The secant is 1 over the cosine. So the graph of secant has vertical asymptotes wherever the cosine is 0. So notice this is the same place as where the tangent function. So the domain x cannot equal pi over 2 plus any multiple of k, pi times k, where k is an integer. So that means you can multiply k of positive or negative. So that tells me that at pi over 2 and then plus pi, there is a vertical asymptote. So let me put that as well. And then the range is the same as the cosecant function, -infinity to -1, and then 1 to infinity. And the period is 2 pi. It's the same as the cosine function. All right, so those are all of the graphs, all the trigonometric functions: sine, cosine, tangent, cosecant, secant, and cotangent.